While USE-2 cables are designed to be water resistant, prolonged exposure to water can compromise their integrity. Water ingress can lead to, firstly, corrosion of metal components. Water can penetrate the cable's outer jacket and cause corrosion of the copper conductors, steel armoring, and other metal components, weakening the cable. Secondly, short circuits can occur. Water can bridge the gap between conductors, creating short circuits that can damage equipment connected to the cable. Thirdly, reduced signal quality can result. Water can alter the electrical characteristics of the cable, leading to signal loss or degradation. To assess the extent of cable damage caused by water ingress, it is necessary to firstly cut the cable back. Open the cable at the point where it was submerged and inspect the conductors and other components for signs of corrosion or damage. Secondly, perform an insulation resistance test. Measure the resistance between the conductors and the ground to determine if the insulation has been compromised. Based on the assessment, you can take the following actions. Firstly, replace damaged cable. If the inspection reveals significant corrosion or damage, the affected portion of the cable should be replaced. Secondly, repair damaged cable. If the damage is minor, it may be possible to repair the cable using appropriate methods such as splicing, sealing. Thirdly, test and monitor cable. If the cable passes the assessment, it should be thoroughly dried and tested. Continue to monitor the cable for any signs of degradation or performance issues. It is recommended to avoid leaving USE-2 cables submerged in water for extended periods. Use proper trenching and drainage methods to prevent water accumulation in trenches. If cables are exposed to water, dry them out as soon as possible and assess their integrity. Consult with a qualified electrician or cable manufacturer for guidance on cable repair or replacement. The National Electrical Code, or NEC, provides guidance on the proper installation and use of cables. It's important to adhere to these standards to ensure safety and prevent electrical hazards. The NEC Article 310 covers conductors for general wiring, and it outlines the requirements for conductor insulation, opacity, and installation methods. Understanding these requirements is crucial for selecting the right type of cable for a specific application and ensuring its safe operation. Furthermore, the NEC provides tables such as Table 310.15b16, which specify the allowable opacities of insulated conductors based on their insulation type and ambient temperature. These tables are essential for determining the appropriate size of conductors for a given load and preventing overheating. When dealing with water-damaged cables, it's important to consider the potential for ground faults. A ground fault occurs when there is an unintentional electrical connection between a conductor and ground. This can create a dangerous situation as it can cause electric shock or fire. To prevent ground faults, it's important to ensure that all electrical equipment is properly grounded and that ground fault circuit interrupters, or GFCIs, are installed in areas where there is a risk of water exposure. GFCIs are designed to detect ground faults and quickly shut off the power, protecting people from electric shock. When inspecting a water-damaged cable, look for signs of corrosion on the conductors and other metal components. Corrosion can weaken the cable and reduce its ability to carry current. If you find corrosion, it's important to clean the affected area thoroughly and apply a corrosion inhibitor. In addition to visual inspection, it's also important to perform an insulation resistance test. This test measures the resistance between the conductors and ground and can help determine if the insulation has been compromised. A low insulation resistance reading indicates that the insulation is damaged and that the cable may need to be replaced. When repairing a damaged cable, it's important to use appropriate methods and materials. Splicing is a common method for repairing damaged cables, but it's important to ensure that the splice is properly insulated and sealed to prevent water from entering. Heat shrink tubing is often used to insulate and seal splices. It's also important to use connectors that are compatible with the type of cable being repaired. If the damage to the cable is extensive, it may be necessary to replace the entire cable. When replacing a cable, it's important to use the same type and size of cable as the original. It's also important to follow all applicable codes and standards. In addition to addressing the immediate damage caused by water, it's also important to take steps to prevent future water damage. This includes ensuring that trenches are properly drained and that cables are not left submerged in water for extended periods. It's also important to regularly inspect cables for signs of damage and to take corrective action as needed. By following these steps, you can help protect your electrical infrastructure from water damage and ensure its safe and reliable operation. Furthermore, consider the environmental factors that can contribute to cable deterioration. Extreme temperatures, exposure to sunlight, and chemical exposure can all degrade cable insulation over time. Regular inspection should include checking for signs of cracking, discoloration, or brittleness in the cable jacket. If any of these conditions are present, the cable should be evaluated by a qualified electrician to determine if replacement is necessary. Another important aspect of cable maintenance is proper support and securing. Cables should be properly supported to prevent strain on the conductors and terminations. Sagging or unsupported cables can lead to premature failure. Use appropriate cable ties, clamps, or supports to ensure that cables are properly secured. The frequency of inspection should be based on the severity of the environment and the criticality of the electrical system. In harsh environments, such as those with high humidity, extreme temperatures, or exposure to chemicals, more frequent inspections may be necessary. Critical electrical systems, such as those that support life safety equipment or essential services, should also be inspected more frequently. When performing electrical work, always follow lockout/tag-out procedures to ensure that the power is energized before working on any electrical equipment. This is a critical safety precaution that can prevent electric shock and other injuries. Use appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc-rated clothing. These items can help protect you from electrical hazards. If you are not qualified to perform electrical work, do not attempt to do so. Contact a qualified electrician to perform the work. Working with electricity can be dangerous, and it's important to have the necessary training and experience to do the job safely. Furthermore, consider using cable management systems to organize and protect cables. Cable trays, conduits, and other cable management systems can help protect cables from physical damage, moisture, and other environmental factors. These systems can also make it easier to identify and troubleshoot cables. Proper labeling of cables is also important for efficient maintenance and troubleshooting. Use cable markers or labels to identify the function and destination of each cable. This can save time and effort when performing maintenance or repairs. When installing cables, avoid sharp bends or kinks. These can damage the cable insulation and reduce its ability to carry current. Use a cable bender to create smooth, gradual bends in the cable. Also, be careful not to over-tighten cable ties or clamps. Over-tightening can damage the cable insulation and reduce its lifespan. Use the appropriate torque settings when installing cable connectors and terminations. Over-tightening can damage the connector or cable, while under-tightening can create a loose connection. A loose connection can lead to overheating and electrical fires. Ensure that all electrical boxes and enclosures are properly sealed to prevent moisture from entering. Use weatherproof boxes and fittings in wet or damp locations. Check the seals on electrical boxes and enclosures regularly and replace them if they are damaged. Consider using surge protection devices, or SPDs, to protect electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment and cause it to fail. SPD can help protect equipment from these surges. When selecting an SPD, choose one that is rated for the voltage and current of the electrical system. Also, be sure to install the SPD according to the manufacturer's instructions. Regularly test SPD to ensure that they are functioning properly. Some SPD have an indicator light that shows whether they are still working. If the indicator light is off, the SPD needs to be replaced. When working with electrical equipment, be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit in the air. Arc flash can cause serious burns, blindness, and even death. Wear appropriate arc-rated clothing and use other safety precautions to protect yourself from arc flash. Furthermore, consider using infrared thermography to detect hotspots in electrical equipment. Infrared thermography is a non-destructive testing method that can be used to identify areas of excessive heat. Hotspots can indicate loose connections, overloaded circuits, or other problems. Regularly scan electrical equipment with an infrared camera to identify potential problems before they cause a failure. Keep electrical equipment clean and free of dust and debris. Dust and debris can accumulate on electrical equipment and cause it to overheat. Regularly clean electrical equipment with a vacuum cleaner or compressed air. Use a mild detergent and water to clean equipment that is heavily soiled. Be sure to disconnect the power before cleaning any electrical equipment. Also, consider using a power quality analyzer to monitor the quality of the electrical power. Power quality problems such as voltage sags, voltage swells, and harmonics can damage electrical equipment and cause it to fail. A power quality analyzer can help identify these problems. Regularly analyze the power quality to identify potential problems and take corrective action. Keep accurate records of all electrical work that is performed. This includes repairs, replacements, and inspections. Accurate records can help you track the performance of your electrical system and identify potential problems. Store electrical records in a safe and accessible location. Train employees on electrical safety procedures. Employees who work with or around electrical equipment should be trained on the hazards of electricity and the safety procedures that they should follow. Provide regular refresher training to ensure that employees stay up to date on the latest safety procedures. Conduct regular safety audits to ensure that electrical safety procedures are being followed. Identify potential hazards and take corrective action to eliminate or mitigate them. Regularly review and update electrical safety procedures to ensure that they are effective. Stay up to date on the latest electrical codes and standards. Electrical codes and standards are constantly being updated to reflect the latest safety practices. Ensure that your electrical system is compliant with the latest codes and standards. Finally, consult with a qualified electrical engineer or electrician for assistance with any electrical issues. An electrical engineer or electrician can provide expert advice and guidance in the design, installation, maintenance, and repair of electrical systems. They can also help you ensure that your electrical system is safe and compliant with all applicable codes and standards. By following these recommendations, you can help ensure the safe and reliable operation of your electrical system.